We'll talk about some behavioral patterns starting in this presentation. We'll first start out with the chain of responsibility and then go through a few other very interesting patterns that are classified under this behavioral pattern. But the first question is, what's behavioral patterns? Behavioral patterns mostly concerned with algorithms or how objects work together to distribute responsibilities among them. So they really are interested in focusing on how objects work together and communicate together. Creational patterns were focused on the abstraction of creation. Structural patterns were more concerned about how objects are related together. But behavioral patterns focus on how they work together, and so it's a workflow or how they communicate with each other to get things done. So let's talk a little bit about one of the very first interesting behavioral pattern, which is the chain of responsibility pattern. It's quite common in applications where we would have a set of objects that have to collaborate with each other and they have to process certain kinds of events. Message passing, messaging, event-driven development is extremely common, and more applications get developed with especially reactive programming and responsive design. We are really interested in providing this kind of capability. So what chain of responsibility provides is, it avoids coupling the sender of the request to the receiver of the request by giving more than one object a chance to handle the request. So the idea is that there are some events or things that need to get done, and so the sender of the event says, hey, I want some work to be done. The receiver of the event may not be just one object, could be multiple different objects, would want to handle it. We don't want to really bother the sender with the specifics of who the receiver really is. We want to be able to provide a very good flexibility where we can add and remove receivers without having to change the sender. So what is the underlying design principle here one more time? Well, it's the open-closed principle, and of course we are trying to decouple as well and provide extensibility. So the main purpose of this pattern is to really provide the decoupling, extensibility, solve the open-closed principle, and in doing so we're going to be applying the dependency inversion principle to solve this particular problem. So avoid coupling the sender of the request to its receiver by giving more than one object a chance to handle the request. Chain the receiving objects and pass the request along the chain until an object handles it. So for example, you might provide a particular object and say, well, I want this to be propagated, so we may be passing this down the chain, and any of the objects in the chain may potentially handle it. Or if it doesn't want to handle it, it could simply pass it along to the next object in the chain. And so this could be a case where we could have one object says, hey, I've got some event to do, could you please handle it? The object takes up this and says, is this something interesting to me? Do I want to handle it? If it handles it, that's great. Otherwise, simply passes down to the next object in the chain, and that in turn may handle it or pass it along the next object in the chain, and this may go on and on and on until maybe eventually no object wants to really handle this. Now, if no object really handles it, the message may eventually disappear. Of course, if that's very important, we can always subscribe a very tail end of the chain with an object that will report back an error. So if you pass an object and that passes the message to another object, another object, another object, how does it really feel? Well, sometimes it feels like it's talking to a government, at least my government here. So you send a petition and that gets forwarded to somebody else to handle, and eventually, of course, that goes on and on and on. And if you're lucky that in the chain somebody eventually handles it, otherwise the last person puts it in the trash can and you never hear back from them. Well, in programming, at least it's not that bad. We really are trying to decouple and provide certain handlers along the way. So let's look at some examples of this. Various types of controls are used in an application. Controls handle certain events while they do not handle other events. Each control may be invoked from other controls. An event not handled by a control must be passed on to its parent control or the control in the chain. So how does this really work in terms of the organization? The idea is we got a client, or this is the source of the event, is going to generate an event, and an event handler may handle the event or may pass it on to the next event handler in the chain. So there are different concrete controls, as you can see, that potentially may handle these kinds of events. Let's take a look at an example of this and see how this could potentially work. Let's say we have some kind of a data source. So we'll say data source, and our data source, we'll call it as, let's call this as, our data source. So our data source is simply a data source that's going to create some kind of data along the way. So we created a data source object. Let's go ahead and assign it to a data source. And we're going to generate some data in the data source along the way. So once we have our data source, let's go ahead and call start on our data source. So data source, and we will say dot start, and this is going to trigger a series of data to be generated. So what is the start method going to do? Well, the start method is going to say while true, and it's going to sleep for let's say a second. So we'll say thread.sleep, and every second it's going to generate some kind of data. We'll keep it pretty simple for us to understand how this is going to work. So this is going to simply, let's go ahead and say this is going to be the sleep method that just gives us a delay for execution. Now, after a sleep, what we're going to do is we're going to generate some data. Let's just create a random number, if you will. So math.random, let's say, and in this case, actually, let's create a random number generator. So we'll say random, and this is going to be random, and this is going to be an object of random that we're going to start with. And in this case, we're going to generate a random integer every second. So random dot, let's say next integer we want to create. And this is going to be within a value of, let's say, 0 to 1,000. And so that's the value it generates. But where does this value really go? That's the question. So let's go ahead and save this into a value. But we want to propagate this value around for handling. So we're going to go to a handler and call this particular processing. Let's assume for a minute that we got one specific handler on our hand. Well, this handler is going to be, let's say, handler that's going to deal with a certain value above a threshold. So let's go ahead and say this is going to be above threshold, let's say hold handler, and we're going to specify this particular handler, we'll call it as above threshold handler, and let's say the value we are interested in is 900. So in this case, we're going to provide an object of this above threshold handler, and we need to first create an object of this handler. So let's go ahead and create that. And what does this handler really do? It contains a method, so above threshold, let's fix the spelling here. So above threshold, so above threshold, so threshold handler. And this is going to be a handler that has a method called handle event. That's what we're going to call this as handle event. So let's go ahead and say this is going to be a handle event. So I guess I couldn't get the spelling correct, but get the point. So I'm going to specify a method void handle. And what is this going to take as a parameter? A value it's going to take as a parameter. Well, in this case, it's going to also have a constructor which is going to take care of this particular value. So let's go ahead and create a constructor for it. And we will call this as threshold. And that's going to be the value that we are interested in holding on to. So now that we have a threshold value, let's go ahead and assign it to a variable, in this case a field. So that's our threshold field. Well, we're going to say if the value for the threshold, so if the value is greater than the threshold we created, then we're going to simply report output a value, and then we will say value will say exceeded. So in this case, we'll say exceeded the threshold. So threshold, and in this case, we're going to specify the value of the threshold that it was exceeding. So great so far. Now that we have the threshold value given to us, how do we go about handling this? We want to register this particular handler with our data source before we call the start. So we could say our data source dot add listener, and then we could specify the above threshold handler. Well, now that we have registered with this, we can call the start method. If we go to the add threshold listener, that receives a threshold listener, and we're going to be storing that value. So we will call this as a handler for this purpose. So we'll create a field called the handler. And in this case, of course, the handler has been registered. Our job now is to notify the handler. So we'll say handler.handle, and then we're going to specify the value that we have on our hand. Well, looks great so far, isn't it? So now that we have done all of these work, let's go back and see how this is going to work. So we go ahead and run the code, and we can see that as time goes on, anytime the value exceeds 900, it's going to report that, as you can see. And of course, if the value doesn't exceed 900, it keeps quiet. But what if I really want a below threshold handler as well? How do we go about handling it? Well, in this case, we could create yet another handler. So we could say low threshold handler. And in this case, we will say call it as low threshold handler equals new low threshold handler. So we'll create a handler again. And this new threshold handler is going to be interested in a value which is a low value. So we could go ahead and implement the low threshold handler again. And in this case, of course, we will say this is the threshold value that we are getting. And we are interested in a low value in this case. So let's go ahead and output that. And we'll create a field for it first of all. And we need to provide a handle method. So we will say void handle. And this is going to be a void method which takes a value. And once again, what this is going to say is it's going to say if the value is less than the threshold, it's going to output, well, we could say value, and then the value given to us is below the threshold, and we will specify the threshold value as well. So far, really good. But once again, the problem in this particular case is that how do we really tell our data handler, the data source, to handle this particular value? Well, in order to handle this value, we could go back and say our data source dot add listener, and we could specify our low threshold handler. Well, if we were to do this, what's going to happen? Well, if we were to do this, we are going to end up coupling our add threshold, our data source with both the handlers. In turn, our data source will begin to fail the open closed principle, because every time we add a new data handler, we have to come back and also add one more code or change the code to add another handler. That's one problem. The second problem really is that how do we know which of these two handlers are going to really handle the request? Well, we have to really loop through, call each of the handlers, and if any handler handled it, we need to say don't go any further, and if a handler didn't handle it, we got to continue with the loop. So what eventually may happen is, in this code, what we would end up doing is something along these lines. We would say for example, well, actually, because they are not common, we would call, first of all, if, maybe we'll call the handler 1, and then we would say dot handle, so handle the value, and we would say if it handled it, we are done, and we will say else, we would say handler2 dot handle, and then value, and then we would keep going like this, and that will become unbearably complex code for us to write. And besides, this will also be not extensible at all. Every time we introduce a new type of handler, we got to come back and fix that mess. So what can we do about this? What can we do to improve that particular code and make it really extensible is the question. So the way to really improve that and extend that code would be to simply let the data source just get one handler and let the handlers decide what to do and pass on to the next handler. So let's implement the chain of responsibility principle here so that we can handle that particular request properly. So how do we go about doing that? Well, what we're going to do here is we are going to simply ask a handler to go ahead and relate back to yet another handler in our code. That's the first step. So we're going to create a handler abstraction. So we'll change this to a handler. That's the first step. So what is this going to be? Our handler we are going to create. We're going to create a class. We'll call it as data handler for whatever name that's worth it is. So we'll create a handler called a data handler. And this is going to be our data handler in this case. And so this data handler, let's go ahead and create a class called data handler. It contains a method void, so we'll actually make it a abstract class. So abstract class, and in this case we will simply say this is going to become a abstract method. So we will say a public abstract void, we'll say handle, and it's going to take the value that it's going to handle. So that is our handler to begin with. Now that we have a handler, above threshold handler equals new above threshold handler. So that's the first handler we are going to create. And so that doesn't have any terminal operation on it. But let's go to our data handler one more time and do something else with it. Let's create a constructor for our data handler. Well, the constructor doesn't take any parameter right now, and we're going to simply say it doesn't do any real work. But we will create one more constructor, and here we will say our data handler, and we will say next, and we will store that into a field called the next field. So we have next, which is null to begin with. We also have a next, which is going to be a value that's given to us. So optionally, we could do either one of them. So now that we have a data handler on our hand, what do we do? The handle is going to be the abstract method. That's great so far. But what do we do when we do receive a request? Well, we want to propagate the request to the next in chain. So we're going to make this method a non-abstract method. So we'll call it a handle. And all that handle does is if there is a next in the chain, it is going to then say, so is not equal to null. Then we're going to simply say next dot handle, and we pass the value. So you can see what the base data handler is doing. The base data handler says, if I have a message to handle, if I have next one in the chain, I'll simply propagate to the next one in the chain. That's all it's doing. So our data handler's job is actually done at this point. Now it's a good time for us to go revisit our above threshold data handler. So what does the above threshold data handler do? The above threshold data handler, first of all, extends from the handler, and then it says, I'm going to provide a constructor in this case, and the constructor receives a threshold, and if I don't give a particular next value, it simply says super with no other data called into it. On the other hand, if I were to provide a constructor where I do provide a handle, we'll say next, in that case, it simply passes the next over to the next particular object. So passes the chain in the constructor to say, hey, you need to handle this for me, please. So that's basically what this code is going to do. Simply pass that along to the base class. So if we look at our handler, so our data handler, that's what we are going to use here. So that's going to be passing up the chain. So this is again our data handler. There we go. So that takes care of the chain. What about the handle method? Well, the handle method says, if I was able to handle the request, then I'm done. Otherwise, super.handle, and then send the value. So notice what this guy is going to do. If it is able to handle the message, it handles the message and says, I'm done. I'm not going to pass this along. If I'm not able to handle the message, I will send it up to the base class to take care of it further. So that is the goal here, is to decide whether we're able to handle it or should we just continue further. So now that we have done this, what's the next step we want to do? Well, in this case, of course, the next step is to implement the low bound or low threshold handler. Well, the same deal with the low threshold handler. What we're going to do with the low threshold handler is specify that it's got to extend the class we have interest in. So extends our data handler, and this requires a constructor to be provided. So we got the constructor for the data handler, and we are going to also provide one more constructor in this case, which is the one that takes the next. But here we will say int value, or rather threshold. And now that we are sending our threshold value, we will store that into a variable. So right there, we will assign it to a field. So that's the threshold we are going to keep it in, and that's what we are going to do. So then, of course, what we are going to do in the handle method is, if we could not handle, we want to process this and continue further. So we'll say else, we can say super.handle and specify the value that we want to really handle. So that gives us an idea about how we can just keep propagating this. So finally, let's come back here, and we're going to pass the handler to this particular add listener. So let's go back to the code and say, hey, I'm going to provide the value for you in the add listener. And so this becomes our data handler, and I'll say handler here, and this becomes our handler. And finally, that's the handler we're going to store that into, and that becomes our handler. So we have decoupled this. We applied the dependency inversion principle to take care of this, as you can see in this case. So now that we have done all of that wonderful thing, let's go back and see what this is going to do. When we are ready to fire up, so this particular sample is creating a data source. It is starting the data source, registered the above data handler. But what about the low threshold handler? Well, we're going to specify this and say, here is our above threshold handler. So notice we did the chaining right there to say, you either handle it, and if you cannot handle it, send it to the next one in the chain. So we're going to change this to a low threshold handler. So now what's going to happen? Our data source is registered with the low threshold handler. When an event happens, the low threshold handler will receive it. If it handles it, that's great, and the event processing stops right there. If it doesn't handle it, then it's going to send it to the above threshold handler, which will either handle it, and if it doesn't handle it, that continues further, and in this case, since there's nothing to handle it, it'll eventually disappear. So to see that this is actually happening, let's go ahead and over here say output generated, and then we will simply say what we generated so we can actually see this in action. So let's go ahead and fire this up and run this code, and you can see in this case every second it generates a value, but nobody is handling it because it's not above or below a threshold. But the minute it hits a above threshold, you can see that got handled, and the minute it hits a low threshold, that's going to get handled also. But when it hits the low threshold, it's never going to go to the above threshold. Well, that's good so far, but to understand that this is actually happening the way we expect it to happen, let's go ahead and provide a different implementation to see that this actually stops processing. Look at 906 right here. Well, 906, of course, is a high value. It's above the threshold. But let's introduce something into the mix. Let's go ahead and say even value handler. So this is going to be an even value handler, and we will store that into a handler. So we'll call it even value handler. And this is going to be our data handler one more time. And let's go ahead and implement the even data handler. So in the even data handler, we're going to provide the constructor one more time, which is our constructor which takes no parameters. We are also going to provide yet another constructor which does take the next and passes it to the base. But what about the handle method? Well, the handle method is going to be much like the handle method we specified in the above threshold handler, but you can see something else is brewing here. This is going to be quite a bit of duplicated effort in the handle, where each time we keep saying, well, if it is this, go ahead and handle this. If it is this, go ahead and handle it. So we don't want to be redundantly calling the super over and over and over. That can become pretty boring, and also it's possible to make mistakes doing this. So now is a good time for us to refactor the code before we come back to use the even handler in this case. So let's go to our data handler, and in our data handler we're going to say, well, go ahead and call the handle method. But what we're going to do in the handle is we're going to create a protected, and we will say Boolean. We'll call it as handle event, and that takes a value. So this Boolean is going to tell us whether it was able to handle the event or it was not able to handle the event. So now we can say in here, well, I received a request as a handler. So I'm going to say if the handle event, so we'll call it as handle event. So handle event, so we're going to call the method handle event, and the value was successful. Then we're going to simply return, we're not going to do any work. If it was not handled and the next is not equal to null, then we want to say, go ahead and pass the message to the handle method of the next guy. So let's understand what's going to happen here. The handle gets called. The handle says, I'm going to let the handle event handle the event. If the handle event was successful, then go ahead and pass it on to the then abort, don't do any more. If it was not able to handle the event, and if there's a next one, let the next one handle it. Now we're going to make this method a final method because we don't want our derived classes to be implementing this handle method. Well, let's see how we're going to fix this now. If you go to the above threshold handler now, we got a little error, and so we can make this as Boolean, and this would become a handle event, which is the method we want to implement. So what do we do here? We are simply going to say, well, it's a Boolean. We are required to return a true or false. So if the value is greater than the threshold, then go ahead and handle the request. And then, of course, we're going to simply return a true in this case. And if the value was not able to handle, then it's going to simply say, well, I couldn't handle, sorry. You take care of it further. And we're going to simply return a false from here. So likewise, what we are going to do is go back to the other code, which is the code for the other one, which is the low handler. And in the low handler, we can simply say one more time that whether we want to handle this or not. So we can specify what we do in this case. Well, on a second thought, we can even make this a lot more simpler. So by going to the our data handler, let's do one more little thing here. How about this? So we could say, for example, let's say protected, and in this case we will say Boolean. So how about this? So protected Boolean, and let's make this an abstract as well. And we will say so is let's say can handle. How about that? Int value. And we will say void handle event. So can handle event. So I'm trying to remove even more duplication. So can handle event and handle event. So what do we do in this case? Let's rewrite this. So we're going to say if can handle event value, then I'm going to simply say handle event value, else we will say if there is a next is not equal to null. Then we could simply say, as simple as we can simply say, well, next dot handle the value given. So that becomes not easier to simply remove a lot of duplication of code in the derived classes. So let's go ahead and fix the code now to the new approach we created. So go back here and say, well, I want to implement a void method here, which is where I'm going to handle the event. And all I'm going to do is simply output that value. And of course, this would never get called unless the value was above the threshold. Similarly, we're going to provide the method, which is the method for can handle event. And we simply say return value is greater than the threshold. Isn't that sweet? So we don't have any duplicated effort and things. We just focused on only thing we should do and not worry about anything else. Now let's go back to the low threshold handler. And in the low threshold handler, likewise, we're going to say this is going to be a void handle event method. And the handle event method says, simply do this work for me and don't worry about anything else. And then we provide the method can handle event, and here we return simply if the value is less than the threshold. Sweet. So that takes care of that as well. We removed quite a bit of duplication. Now you may wonder, hey, what about this duplication in the constructor? Wouldn't it be nice if we can remove that duplication? Well, unfortunately though, Java doesn't quite allow that to be handled properly. There are other languages where you don't have to implement a constructor like this. It'll just carry down the constructors from the base and implement it. So at least we could remove this in those languages. But unfortunately, that's not the case here in Java. So we did that so far. What's the next step? The next step is to handle our even value handler. So let's go to the even value handler. And here we are going to say, well, go ahead and provide for us the two methods. Here I'm going to return value mod 2 is equal to 0. And then, of course, I'm going to simply say output. And the output is going to be handling, let's go ahead and say a value. And then we will say value is, let's say, even. So this will be handling the even values in our request. So now that we have done that, let's go ahead and put that into the chain. Where do we place that? Let's place that between the low and the even. So right there is the even handler. I'm going to make that the even handler. and I'm going to specify this is the above threshold. So low will talk to even will talk to above, and above is the last one. It wouldn't handle anything. Let's go ahead and run this code and see what it's doing. Well, there we are generating some values, and notice the minute the value is even, it reports it. But if you notice though, when the value becomes really below the threshold, even though it's even, it was handled by the low threshold. And then of course, if the value is a large value, the above threshold will handle it, 923. And you can see that happen, and you can see that it propagates and goes through. As you can see, that's again a high value threshold. But if you ever receive a even number which is high, you would notice that it's never being handled by the high threshold, but by the even itself. So you can see how we have several things in the pipe. So let's look at a couple of output here. These are all normal values that are not handled by any event handler, so they are lost. This one is handled by the even handler, and then you can see that these values are again lost, and then finally we can see that we have a even value again being handled by the even handler. This one is a low value, even though it's even. The low handler is the first in the chain, so that handled it. And then of course, if you look further down, we have a value 923 which is high, which was handled by the high handler because nobody else picked it up. However, if you notice over here, we have a relatively high value 904, but it was not handled by the high handler because the even handler intercepted it. So that shows you how we can have some of these implemented very nicely in our code. We can probably reduce the noise just a little bit here in the data handler because we are using a null, and I consider a null to be a smell. So there are a couple of different things we could potentially do, for example. So for instance, what we could do is we can go back to this code and let's do a couple of things. I want to remove this generated message so it's not as noisy. So let's go back to this code and do a little refactoring. So we just removed that particular message. So now we should only see the message when one of the handlers actually picks up, not otherwise. So that's great so far. But let's get back to the handler and remove some smell of the null. So right here, we are going to simply say equals, we'll say optional dot empty, and we have made it an optional object. So we'll say optional, our data handler, next is going to be an optional object. So now that's optional empty. We don't have to really worry about that anymore. And now if the next is provided, we're going to say next is equal to optional dot of the next value we received. So now that we have placed this into an optional, look at how painless this becomes. So else, what do we do? Else optional, so that is the next dot, if present, we want to then say, well, what do we do? On the optional, we want to call a method. And what method do we really want to call on this case? So we will say here is the next that's coming in, and we'll simply say next dot, and we're going to get the value on the next and call a method. So we can simply say next dot handle and ask it to handle the next value. So we'll simply say value right here. So this gives us an ability to pass the value using a lambda, and we remove the smell of the null in this case. Let's refactor it just one more time after we do one little work. Let's go ahead and run this and see what it does. So when it hits the threshold, you can see the threshold is kicking in. Well, that seems to be kicking in the even threshold for a while, but let's make sure, yeah, there you go. Some another threshold also kicked in. So that's great so far, but we can simplify this just a little bit by using method references. So we can go back here and say, well, this is going to be the next one I'm bringing in. So I want to call the handle on the next one. So how about that? So we're going to simply say this is going to be a next one on the object we have on our hand. So we can simply call that on the object. Well, we know that next is really not null, but this gives us the actual object that we're going to call the method on. So handler, which is going to be our data handler. So we'll say our data handler, and this is going to be the handle method. Well, unfortunately, in this case, I'm wrong because we do need the value to be passed in. If there was no value to pass in, we could have simply used a method reference. I was a little eager to do that, but not in this case because we are passing a different value than next. If this were next, of course, we would have managed it very effectively. Well, maybe one idea would be to write another method which will then receive the value and call the handle, but that simply is not worth it. So that's basically what we have done to remove our null smell here. So we can see how we are using a chain. Let's quickly review the code we just wrote. So our data handler simply starts with a next object in the event chain. When an event handling arrives, it checks if it can handle the event. If it can handle the event, it simply handles it, and the event does not get propagated. If it cannot handle the event, it checks if there is a next one, and if there is a next one, it lets the next one handle it. So all our event handlers that we are using in the code simply are implementing that particular abstract class, and they only take one responsibility. They tell whether they can handle the event or not, and if so, they handle the event. So we can then go back to seeing how this would help us further down by looking at the code for the user. We have registered only one event handler here, and that simply propagates to the subsequent event handlers, as you can see in this case. So what did we see so far? We used a chain of responsibility. More than one object may handle a request, and the handler isn't known ahead of time. So we don't want to bind couple to specific handlers. One of several objects may be the intended receiver of these events, and we don't know which one it is ahead of time, and so a set of objects may handle the request dynamically. Now there is one option here. When an event handler handles the event, it does have an option of still propagating the response to other handlers if you want that to be. So that would be a special case of chain of responsibility where it can pass it down the chain. So what are the consequences? It definitely addresses the open-closed principle. It uses the dependency inversion principle as the solution principle. It reduces coupling quite a bit. Now the handler is coupled to another handler, but none of these specific handlers are depending on any other handler. And our data source doesn't depend on anything other than one handler, so that's definitely a lot minimized coupling. It's very flexible to assign responsibility to different handlers. It distributes the responsibility among several objects. Any one of them could handle it. But of course, the receipt is not guaranteed. As you saw in our example, if the value is not below a threshold, not even not above a threshold, it never gets handled. So there's no guarantee of handling in this particular case. Now, how does this relate to other patterns? Often, a composite may use a chain of responsibility to propagate and let its composites handle the messages that come through. And parent may act as a successor of the event handling potentially. But if you notice the responsibility, chain of responsibility pattern, the structure is a lot like the decorator pattern. However, the intent is quite different. In the case of a chain of responsibility, our goal is to handle events, and any of the objects may handle the event, and an event may go unhandled potentially, and it is quite possible that only one of them will handle the event, not many of them. In the decorator, on the other hand, we literally are taking an object, but we are enhancing the capability of that object through other flavors. As a result, in the case of a decorator, we typically will have a situation where all those operations cumulatively are performed on the object because we have enhanced the object using the decorations. In the case of chain of responsibility, we don't do multiple things. We handle, one of them handles it, and none of them may potentially handle it. So the difference is in the intent of the two patterns, even though the structure may appear to be a lot like one another, even though you could argue that it depends on how this is being implemented. So you could call this a decorator or a chain of responsibility more based on the intent rather than simply looking at the structure itself. But that's true of several patterns. You don't want to simply say this is this pattern based on the structure. You also want to consider the intent of the pattern as well. So we talked about the chain of responsibility, which is the first behavioral pattern we discussed here. We'll continue further to discuss other patterns in this category moving forward.